Well, hi, good morning. Thanks so much for joining me in my shop here. It is August 8th, 0808 today. So yesterday I replaced one lone electrolytic capacitor in this radio. It's the capacitor that's in the FM detector circuit, the critical capacitor there. There it is. And put a new one in. It ran the radio. Didn't really notice any dramatic improvements. It was probably a little bit better than it was, but nothing too dramatic. In particular, I'm keeping my eye on the FM stereo indicator light, which indicates whether the receiver is switching into stereo mode or not. And it takes a little bit to get it to do that. Doesn't do it on its own. Something still is wrong inside this radio. It needs to be corrected. It could be nothing more than alignment at this point, but I doubt that. When I took this first capacitor out, I gave it a test. It failed the test. Not surprisingly, there's 3 or 4 more similar capacitors in here. Blue one here, and down here, and then this big metal guy here. I think I got to change those out. And that may well improve the operation of the radio just doing that. I'd rather not attempt to fool around with alignment just yet, because I think there's still problems being caused by defective or weak components, like the capacitors I just described. So until I get the feeling that things are running the way they should be running, I wouldn't really want to put too much time into alignment. So today is about this blue, that blue, and this blue capacitor here, and this metal one. I'm going to change those. I don't... Oh, you know what? There's another one. There's another one hiding over here. But I spotted them. May even be another 1 or 2 in there. Oh my gosh. Having said that, I just looked down at the amplifier board. Maybe I shouldn't have. So what do we see? In the same blue type. 1, 2, 3, 4, 5, 6. Well, that would keep me busy for a day. The owner of this receiver made a comment to me about he'd hoped I would take the boards out and work on them outside the radio, and I said that's not very likely to happen because it's a lot of work and risk to get a board like this out. There's many wires coming to it. And who knows what kind of problems might ensue if you try to remove one of these boards. It might be easy, it might not be. Maybe I should take a closer look at that. Maybe it's easier than I think. Look at this top board. Well, okay, so it doesn't seem to be a huge number of wires. Yeah, there's quite a few wires. Yeah, quite a few. This lower one. Likewise, it's just got wires going all to it. I think the risk of creating more trouble than solving it is too great, because there's a efficient alternative here, and that is just to work on the boards with them in the radio and flip the radio around as necessary to get at the parts. Oh my gosh, there's even more. There's one up here. There's this one's popping out the end like this, like the one I changed. Wow, there's quite a few. This might take more than a day to do. The day being an hour for me. Okay, let's stay focused on the radio circuit. That's where the trouble is right now. Appears to be right now. I'll do those and we'll see what happens. Okay, that's my plan. Okay, that's the capacitor, a little tiny guy here, 1 microfarad. Michael Faraday. Some would say he was the smartest man who ever lived. Michael Faraday, the greatest scientist ever. Died young. Okay. Let's see what the Faraday reading is on this. So it's telling me it's 1.7 nanofarads. That'd be a 1.7 microfarads. It's supposed to be a 1. It's reading higher than a 1. The loss is 20%. Yeah, I think that's bad. Okay, first one, I will put in a replacement for this guy, and go on to the next one. Okay, next capacitor is out. This is a 10 at 16 volts, 10 microfarads. Here we go. Drum roll. Ta-da! Supposed to be 10s, measuring 13. And you just expect older components to lose or their values to drop over time, not go up. So a 10 has become 13, almost 14 here. My experience tells me that that indicates the capacitor is leaking. And that's why the instrument's being fooled into giving a higher reading. Now, electrolytic capacitors are all a little bit leaky, but of course, I guess over time they can become more leaky to the point where they're not really doing their job. You'd kind of wonder though, wouldn't you? If the instrument feels the capacitance to be 15 on this, wouldn't the radio feel the same thing? Is it 15? I don't know. Okay, so I'm going to put in a new one there and move on to the next one. Maybe I better test the radio after I do this next one here. So I have a tray full of NOS blue capacitors here, just like the ones that are in this unit. Not necessarily the same vintage, but they could be. I'm going to test one of these just for fun. This has never been installed anywhere. It's, NOS, new old stock, 47 volts, 40 volts, 5%, 1 or 10, 1 or 10. I don't know. Mexico. It says Mexico on it. Well, I don't know. It's either a 1 or a 10. Looks like a 10 to me, this size. Okay, let's see what happens. What happens to a capacitor that's spent its life laying around? Just been on vacation the entire time. This is saying, oh my gosh, look at that, 60 microfarads. 60? Can I find a 60 on there? Well, 47. 47. That is probably not a V, it's probably a U. It's probably 47 microfarads. I need to put this on a different tester to really get a good test. Let me try a bigger one. Again, same old style capacitor. Well, isn't that something? You pull this blue off and it turns into one of those. This one is 100 microfarads at a very low voltage. $115. That's serviceable. 0.3% doesn't sound like anything to me. So, I guess the name of the game with these old parts is you want to check them before you install them. Now here's an actual capacitor I could use. This is 16. This is 10 at 16 volts. No. The one that was in there was 40 volts. 40 volts, right? Wasn't it? Here it is, here. I think it was 40. That doesn't mean it has to, 16. It's 16. So I could use one of these. I could use this. $15, eh? It's supposed to be 10. Now, based on what I said earlier, I'm going to use that. Okay, so I'm going to find a check this out. I have another interesting tray here. Hey, where's my interesting tray? Someone's done away with the interesting tray. Well, I'll be. The tray is gone. Where did my interesting tray go? Well, I had to hunt long and hard. They're a little tiny 10 at 25 volts. Just what I need. I got lots of these little guys here. This is the stock from a repair shop that closed up a few years ago. Some of the stock from that shop. So here we are. Now, I'll put this guy in and we'll go on to the next. Go on to the next. Okay, that's 3 done. Next one to get out here is this guy up here. There he is. Okay, I'll hook him. Got him. Okay, now on the back side. Let's see how good I can do this. So, okay, so my tool, I would say, is pointing right just, well, in here somewhere. I'm pretty close to the top here. Whoops, I am hooked. Well, up in here. Some of the solder connections are actually up under this aluminum chassis here, tucked up under. Look at that, a gigantic ground connection here, and there's another one over here. Look at that. Well, there's one in the middle here too. There's one over here. There's a whole bunch of these. Wow. Okay, that's why I don't want to take the board out. It's a monstrous job. Well, I don't know. I'm going to take a guess. Here we go. Down on my knees here, by the way. Is it this one? Doesn't look like it. How about this one? Now in the course of doing what I'm doing right now, I can introduce trouble into the radio. There it goes. So it was that one. Okay. So now what I need to do, I need to hook the other end of the same capacitor. What do I do with the soldering iron? Oh, smokes! I didn't put it back in its holder. That's bad form. Okay, so here he is. You know what I'm going to do? I'm going to notice which way is which on this for once. Okay, so the band is this way. Band is this way. Yeah, I think I'm going to be sure of that in a few minutes. Okay, straight across about an inch. Straight across about an inch. Straight across at about an inch. Oh boy. Maybe there. Oy, oy, oy. I don't know. Let's see. So it's straight across from the one it came from. Which one was that? boy. Well, I'm going to guess it's this. Very awkward. Lots of smoke. It was that one. I guessed right. Okay. Good job there. There he is, just hanging here. We got him. Band this way. So this is a looks like 25 at 6.4 volts. 6.4. You know, why isn't it 6 or 7? 6.4. How can it be that precise? So the end of this looks a little roughed up here. That was the value again? 25. So I'm going to just, I'll check that on the schematic too, just be sure. But next one to be changed. Oh, we got to test that guy. Yeah, let's test him. Let's test him. $25, eh? Pretty small. Sure does look like 6.4 volts at 25. It's kind of backwards. I usually write it the other way around. What do you get? Ooh. You really had to think about it. 50 microfarads. 50. And it says 25 on it. Yeah, I'm gonna find this on the schematic and see what it says. Okay, so looking at the layout here it is right here. C218, 25 at 6.4 volts. There it is. So I gotta find a 25 at, say, 10 volts. 25. Okay. Okay, left now with just two more electrolytic capacitors on the radio board. And one is here, this big guy here, and the other one is this one over there. Let's go for this one next. This guy. Okay. Up near the top of the board, again almost out of view because of the chassis covering the edges of the board here. Way up in here. Oh my gosh, it's way up in there. So right at the top, it's right at, so one connection is right at the top. The top row is really the second top connection in board. Oh my gosh, it's way up. It's way up under here. Yeah, hacksaw a big hole in the chassis here to get at it. Let's experiment here. I'll pretend this is my soldering iron. It's got to go up here. Well, it's doable. And the other wire is down in here somewhere. So it's just this upper one. Where exactly? Let me put my finger on it here. Oh, I got this on it already. Okay, we'll use this. Okay, so it gives me some notion what I'm pointing at. Some kind of notion. It's got to be right up at the top. Anything else higher on the board? There is not. So we see connection. There's three tight together connections. Is this one of them? Son of a gun. It's really kind of tricky. It really only looks like there's one wire and then this. And how far in is that on the board? Let me measure it. Okay, so it's a little wider than my pliers on the edge. a little wider than my pliers from the edge. It's right back there. But I see 1, 2, 3, 4 solder joints right tight in a row. This is probably that first one. Why do I see 4 of them right together? It's right in line with the big capacitor here. Right in line with the big capacitor. So yeah, they're just a little further over. Yeah, you know what? I think this is the first one. Okay, I think I know which one it is. Now if I pull on it like that, I don't think I'm going to get it out, because I'm pulling on the other lead kind of. Yeah, if I pull on an angle. If I pull on an angle, I'll be pulling on it. Okay. So you've watched me this far, so watch me get this thing right out. Just reset my soldering iron. Okay, so my guess is that one there. Let's just clear the way. Okay. Now, soldering iron. Get a grip. Pulling on an angle. Oh, son of a gun. I can't really see it. Where'd it go? I think it's right here. Something fall out. So I don't think it's going to pop out. And I don't think I did anything there. That's what I do. I bent the capacitor. Basically, you know, I can hold this capacitor with my fingers. Yeah, that's way better. Okay, now I'm going to stick my head right in front of the camera here. I don't think I can avoid it. Okay, get a grip on it. Okay. Just come out of there. I can see it moving. Okay, we'll try the cold joint thing. So what I do is I heat up the joint, then wiggle the component, and with some luck you'll create a cold solder joint, and the component wire will not be soldered in anymore. And that's I think what I succeeded in doing. Feels loose. So we'll go for the other wire now. The other wire is down lower, somewhere down in here. Wow. Take a guess. I don't have to take a guess. I have a diagram I can look at here. Okay, let me study out here. Okay, so this is the capacitor I'm pulling out. It's on this angle. I've got this wire loose, ready to come out. I'm trying to pull this one out now. So I see 1, 2, 3 solder points coming kind of straight down, first over from here, and this is a wire. And look at that, they're even showing it a wire here. So this is all correct. So I follow the wire, skip, and that's the guy right there. Okay. Okay, so get a hold of it. Yeah. Let me get a pointer here. Where was it? Here's the wire. You go down 1, 2. It'll be this guy here. We're going to try it. I'm just make sure I got a good grip on it here. This is also going on quite an angle. It's going on quite an angle, a bit of an angle from here. It kind of landed over here. Okay, I can burn my fingers this time quite easily. It was down 3 from the wire. That would be this one. I follow the plan. I don't think it's that one. Okay, not that one. How about this one? No. Well, how about this one? That can't be this one. I can feel it's not that one. Maybe it's way down here. How far down does it go? It goes nowhere. It's still at the top of the board. Basically, skipping over one connection. It's this one. Yeah, it's definitely that one. Okay, I'm going to keep it wiggling. And hopefully it doesn't freeze. It froze. Come on back loose again. Okay, I think I got both connections loose. I should be able to yank that guy right out of there. Although yanking is not a good procedure. Yank. Right out of there. Okay, who's not coming here? Let's pull out the one lead. Probably has a little bit of a hook on it or something. There, that one's out. Okay, that guy needs a little assistance. Put the top here. How's this? I don't need to desolder something. I need to push it through and cut it. Where is it? My view of it is blocked. Okay, we'll assume it's a little piece of solder that's holding it in. Son of a gun. Okay, how about a little more power on it? Hey, how you like that? Got it out. It's probably just a little blob of solder holding it. Okay, I'm going to give them the test. This one's a 20, is it 25? 25 microfarads at 20 something volts. 25 microfarads at 25 volts. 25 and 25. Wow. Should be fairly hard for me to make a mistake with that. 25. 25. Here we go. What's he say? So it's measuring 29. Actually, it's not that bad, is it? But again, the 29 is higher than 25, and I do think that indicates some amount of leakiness. Why don't we do this on another tester too? 25 volts. So I've got a 50 volt tester over here. I'm going to give them the works. Stress test. So you say you're good for 25. What happens to you at 50? Oh, I gotta make sure I got the polarity correct here. Yeah, I wouldn't want to ruin this capacitor now, would I? Can you see that some of the insides are protruding there? A little bit of that brownish tan color, looks like paper. It's kind of what it is, protruding. That's not a very good sign. Okay, so the idea here is hit the switch, apply the voltage, charge goes in. During the charge flow, my little eye here will close. And when the charge stops flowing, the eye opens. If the capacitor is leaky, charge keeps flowing through the leak and the eye stays closed, or all the way, or to some degree. This capacitor on electrolytic setting, this eye should pop open fairly quick and look just like that. 50 volts, or it may explode. Can't be sure. Okay, so it's getting there. It's getting there. Hard to see in the camera, but basically this guy was serviceable. But not for long. Maybe only 10 to 15 more years. So I'm going to put another one in there, and then we only have one more to go. Hey, I'm getting there. Okay, got that one done. That was actually easy compared to the last one. And now, talking about the last one, this guy right here is the same technique. Hook and pull. It's just about the center of the transistors here. Oh, right in amongst all this. Okay, so we have a coil back there. There's a connection, so it's that one right in there, right. Oh boy. Okay. I think it's this one right here. What do you think, radio? Oh, the radio thinks I'm wrong. Oh boy. Okay, can it be lower on the board? Okay, so maybe this one here. The answer's no for that. What am I left with? Right up under the coil. No. As we come across from the coil, there should be two connections very vertically close. Isn't it this one? Sure feels like it. What have they done here? Just one right above that. It's probably the resistor. Or am I not looking high enough? I'm not looking high enough. That's what it is. They're up under this, under the chassis again. So we have the coil, ground piece. Wow, there's one way up there, right up at the top, just off the coil, right up at the top. That's the resistor. Okay, so right up at the top, and then just over and down, it's this one. Okay, let me get a grip. I think I got it. Once again, I suppose I could study the diagram. There we go. That was it. That's one out. Now the other side, same height. Oops. Same height. No. I'm down too low here. Yep, that was it. Just as I was concluding it wasn't it. Now where'd it go? I think it fell right down under here. What did we get? We got a 125 microfarad capacitor, 16 volts, 125 microfarads. Okay, I'm off to find one. What was it again? 16 volts. Okay. So 125 is an odd size, and I've got lots of hundreds at various voltages. Anything over 16 volts going to do. If I put 100 in there, is that going to be too small when it's calling for a 125? Seems to me if 100 would have done it, they would have installed that, because that's a very standard size. What exactly this capacitor is doing, I don't know. I haven't looked. So, okay, so it's reading 500 nanofarads. It's reading 0.5. Ooh, wait a minute. 0.5. That's a little off, isn't it? It says 125 right on it. Microfarads for sure. Look at the size of it. Let's try it again. Well, this is one sick puppy. Again, 0.5 microfarads. It should be 250 times as strong. Wow, what's this thing doing in the radio? Let's take a look at this. It's testing very, very poorly. I wonder if I should use another tester on it. Yeah, let's do that first. We'll put another tester on it. I won't test it for leakage. Oop, let's do it. What I'll do is I'll test it for its capacitance on here. Just see what it says. Plus, and I'm not sure polarity matters for this test. Okay, we're on electrolytic, and we're looking for something around 125 on this scale. So I adjust this until the eye pops open. Hello, eye. Hello, eye. Pop open, eye. Well, that's a pretty bad sign. Let's try it. 0.1 to 50. Okay, so there's a shadowing thing happening here, which I'm sure you can't see. It's a no-show. 20 to 1000. So 125 is definitely in here. 125, at least not showing up at all. Okay, well, let's do the leakage test then on it. Why not? This is supposed to be able to take 16 volts. I'm going to put 50 on it. Yeehaw! So, look away, look away. Just popped right open. Did you see it? How quick it popped open? 125 microfarads takes time to charge on this machine. This should have not popped right open. This is an absolutely El Defecto capacitor. That's two of them now we found in this set. Really defective. So this could have an impact on the radio's operation. Oh, we're going to look at where it is in the circuit. Right. Okay, let's put the circuit up and have a look. Just to get the proper part number here. 204. 204. So we're going to try to find 204. Yeah, this might not go well. Let's see. Let's shrink this and turn it. So that's in the radio circuit here, and I think it's over this way. Yeah, can you find 204 in there? Well, it's going to be one of these electrolytic ones, so we don't have to look at every part, just every electrolytic capacitor. Here's one down here. C16, C232, C227. It's 204 we're looking for, right? It's 204. Oh, these are all sideways now. 204, and what's it connected to? What's it hooked up to? Coil? I don't know. We don't really know. It's somewhere near this Q202 and this L202, big coil. L202. There might be some trouble spotting that in here. Back to us. I think I do better with a capacitor. Let my eye wander now. Look at that. It says 125, 16 volts. C18. Near Q11. No, that wasn't the case up here, was it? Q202. No, it's a totally different. Oh, am I on the wrong? No. Am I on the wrong circuit board? No. 202. Well, we're not going to find it here. Did they number these in the usual way? That's way down here then. 204. There it is. I found it. Wait a minute. It's a different reading. Wait a minute. 204. 204. 25 at 25. 204. I can't be wrong about that. 204. Let's zoom in a bit on it here. 204, no doubt about it. 25 and 25. What's happening? What's happening? Okay, let's go down to the parts list. Parts list. Because we can add to the confusion here if we do that. Let's go down there, up there. Let's go somewhere. Here it is. So now we're looking in the AM/FM printed board assembly, and we're looking for C204. C204. 25 and 25. Is there a 125 in here? Is there a 125 in here? You know, that capacitor looks different than all the rest. This would be microfarads too. So it's electrolytic. They don't really denote electrolytic. So we just look for big numbers in microfarads. That's it. There's no. That's it for that board. Look at it again really closely. Capacitors, polystyrene. Oh, here they are. They are named electrolytic right here. That's that one. Did C204 get changed and somebody used a junk box capacitor to do it? And now that junk box capacitor has failed? We don't know. Don't know the history of the work on this guy. Sure doesn't look like it. I mean, that just looks like it's been there. I'm looking at it again. Oh my gosh, what a quandary. So we got three problems here. One is everything says it's a 25-25, but it itself says it's a 125. I'm looking at it again. There is no 125 microfarad capacitor. It would have to be electrolytic. Is it showing up on another list somewhere? Another list of capacitors. If I find it, I'm gonna fill my pants. Oh my God, is that it? Center panel assembly. Oh, center panel assembly. Center panel assembly. You don't say board. Center panel. So I'm looking at the radio. What's a center panel? Well, there is one, but that's at 16. This one is at 16. Hey, what's going on here? What is happening? C15 in the center panel assembly. So C15. I don't know, should I hunt that down? Wouldn't it look the same as the one I just pulled out? Is there another one? Is there another? Is there another 125? 125. Oh, there's another one over here. C128. So these are common in this radio. So it's possible this was a change. This schematic was produced. They produced a number of these units, and then somebody said, you know what, this 25 isn't enough. Let's put another 100 in there. Okay, 125. And that's what went on. Sometimes there's notes on changes. Sometimes there are notes. Note, we have changed things. Blah, 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 blah. Warranty, warranty, warranty. There's that symbol. How they ever came up with that, I don't know. It looks like a poorly drawn arrow. Where they ever got that from? What am I going to do here? So it's kind of a toss-up. 125 is a big difference from 25. And 0 is what was kind of in there, in fact. Oh my gosh. How do I get into these quandaries? I'm looking at stuff too closely. I shouldn't be looking so closely. Okay, I go back on the schematic, and what is this capacitor doing? As if I can probably figure that out. I probably can't. Well, let's see what we come up with. So the 2204 is here. So it's putting a powerful ground at this point. You have 2,000 ohm resistors. What are they all doing? They're all fooling around with this. And what is this? This is the IF amplifier, one of the IF. This is the main IF amplifier right here. And goodness knows what's going on here. Yeah. Well, it says antenna. That's a good start. Yeah. I'm not going to be able to identify what this is doing. Typically, large capacitors connected to a ground point are trying to snuff out RF signals. This is a very large capacitor. There's a chance it's trying to snuff out any hum that might be left from the power supply. The capacitors in the power supply must be whoppingly huge. Where are they here? Thousands. So if you throw a little, well, it depends on the circuit, how big a capacitor you need out here to do the job, but that could be what it is. Just a quieter, a snuffer, or an RF stealer. Trying to get RF out of this. Why? But this is an RF amplifier coming right from the antenna, right here, right from the antenna. I think. Yeah, I don't know for sure. So what happens if you go bigger or smaller? That's the issue I'm toying around with here. So what if I follow this? Then we have that 25. If I look at what's in the radio, in the radio it's 125. That's a big difference. In this position, there's a chance you could put the biggest capacitor you want in there, except for one concern, and that is charging current pulled through these resistors, or somewhere else, pulled somewhere else through the current, through the circuit rather, and burn something out because it's so much charge current for so long. So you just can't go infinitely big here. Well, if it was 125 in there and the radio survived it, assuming it was a real 125, and somebody didn't replace it at some point for some reason, why wouldn't I just accept a 25? Why don't I put 100 in there? Split the difference. I have lots of hundreds. Why don't we put 100 in there? It's a lot better than 0, what's in there now. Okay, that's the deal. 100, taking into account everything. Even though I kind of raised my certainty there, I'm still having a lot of trouble with this. The 16 volt capacitor in where it's calling for a 25 volt capacitor. Did I get the right, is this right? Did I do this right at all? Did I identify it correctly? Let's just go through that again. So I pulled this guy out of here somewhere. Out of there. He's up high on the board, just over from here. Oh my gosh, what are you looking at? You're not looking at the thing there. Here. Yeah, high on the board, over from here, that way. Right below this transistor. Can't possibly be wrong. A great big capacitor. You're going to show up on that diagram. Well, yeah, great big capacitor. Wow, this doesn't show the physical size of the capacitor. Where'd it go? Where did it go? I've lost track of everything here. I've been in here too long. Here it is. Oh, I'm confusing two things. That's what it is. I've gone back to the old capacitor here. C204. This isn't, that was C204. Jim, you already got yourself pretty confused on this. Let me just straighten this out. Okay, totally, utterly confused. I'm not confused now. So we're over here. There's the 125. Okay, now we're cooking. 217, 125. Boy, I feel a lot better now. My gosh. It's amazing what you'll dream up to try to explain what you're seeing. and Dream Up is the word for it. Okay, that's good. So we need a 125. I'm going to have to match or parallel a 100 with a 25 or something like that to get to 125. I have nothing. I have hundreds and I have 200s. I don't have a 125. What if I stick a 200 in here? Why would they do that? Okay, so to get to 125, the best I can do is take a 100 at 50 volts and a 22, unfortunately at 250 volts, kind of a waste of a higher voltage capacitor. I got to parallel these two guys and then stick them in, stick them in. Yeah, there's no problem with space or anything. Okay, I'm gonna do that. Quick like a bunny. Don't want too much heat to go in. There we go. Ooh, did I hear a little bit of CB there just now? I have a CB radio on in here with an antenna here. It's not outside or anything like that. And when the skip gets really high, we can hear it. Okay. So I'm going to put this in a proper polarity. Well, we've reached the point now where it's time to test the radio. I've replaced all the suspicious capacitors. Well, maybe not all of them. There could still be more defective parts in here very easily. So, time though to test the radio. Now I've gone and done 6 capacitors without testing in between. I wouldn't recommend that to anybody, including myself. If I've made a mistake, or worse yet, made a couple mistakes in there, the situation will become disappointing. Okay, so we're going to start on with the FM radio. Volume down, speakers on, power off. Let's put on the power. Okay, it did lots of capacitor work, although it's, inside the circuit here. I can't imagine throwing the switch and popping a fuse in my house or something like that, but I do have the dim bulbs in the circuit just in case. Okay, here we go. So far so good. We're using 115 big volts. Come on, radio. She's quiet. She's oh too quiet. Why so quiet? Let's go to AM. Stone quiet. Everybody stop. Freeze for a minute. Hold the fort. The light didn't come on. Oh, I loosened the light. Okay, power off. Put the light in. Yeah, it all comes down to the light. Does the light light? The light is in. Here we go. Oh, son of a gun. Something, the sound of something frying up, but I think it's my imagination. No sound coming out. Okay, power off again. Did I discombobulate the speakers? Doesn't look like it. Well, that could be in a bad spot now. I should have taken my own advice. I should have tested this guy after every part that I did. Why didn't I do that? Because it would add another half an hour. Now it's going to add half an hour. What dumb thing could I be doing here? that if I wasn't so dumb, the radio would work. So we're on AM. Volume, I turned it up. Set is off right now. Bass, treble, balance, controls in the middle. AC on, reverse, speakers off. Oh, I was hoping there'd be some magic there, but there isn't. Well, let's stick some kind of signal into the phono input and see what happens. Yeah, this is not what I want. I wanted to turn it on and go, hey, look at that, it works better than ever. So we're going to flip it to phono. Okay, we're on phono. And then I'm going to go stick a signal into the phono jack. Is that me clicking or? Yeah, it's me. It's me clicking with this. It's this thing. Any little sounds now? The sound of parts burning up. Again, volume up. It's just zero coming out. This makes me think I did do something else is going on here. That wasn't even a sentence, was it? Let's go back to radio. AM. We know there's noise there. Hey. Oh boy, there's nothing. Oh no. There's nothing happening here at all. What have I done that I don't realize I've done? And if you know, you shout very loud at your screen right now. So pop and a hum. Headphone jack, I have the feeling it's the very same output as the speakers. So, but maybe not. A pleasant hum. There's nothing else coming out of it. Now, did that cut the speakers off? I don't think so, eh? No, I think the speakers are still speaking. Okay, let's go back to doing the phono thing. So the idea is I'm now going to inject a signal into the amplifier and find out what happens. How can I do that? Stick this in. The phono jack. Phono jack. Get something a little bit better than that. A little bit better. I don't think that's good enough. Oh, heard that. Okay, amplifier's working, nothing coming out of the radio. I wonder why. Could it be because I did a whole bunch of component changes and didn't bother testing what I was doing? Oh, I've done a dumb thing. So that's a lesson. There's a lesson. Unfortunately, I've learned this lesson too many times now. Could be a component solder joint didn't quite take, and if I just wiggle these components, I will discover that. Let's turn the volume down a bit. Take the headphones off. Destroy my hearing. And we're going to do some wiggling. Okay. I hate sticking my finger in like this. Well, I think that's it for today. I'm going to have to end it here, unfortunately. and we're going to have to troubleshoot this thing to figure out what I've done to it. I'm a fool. Shame on me. Oh, I'm not going to feel all that great for the rest of today, but you go ahead and have a good day. We'll sort this out tomorrow and be happy again. We'll see ya.